Hello students, here we come with one more practical related to CAD/CAM, that is computer aided design and computer aided manufacturing. Under this practical, what we are going to do is we are going to generate G code and M code for a particular job which is to be performed on a CNC machine. So as you all know that with respect to CNC machine you need to insert a code, and then that code will be processed by the help of a controller and your machining operations will be performed upon your machine. Now for that there are different software available. The software that I'm using is Autodesk Fusion 360. The reason is it is freely accessible for all the university students. So if you have your college email ID, then you can go and register for free and you will get a free access for 1 year. I will be providing the link in the description box. Second important thing, there are all multiple what we can say features that are covered into this single software, so it is easy to transit between different options. So that's the reason we are going with this software. So once you have opened this software, here this is how the window looks like, and then here in the top right corner you can see your name as your login. Under that there is a preferences option from where you can see change the setting of your workspace. Okay, uh, here is your workspace. So under that you have different options of design, generative design, render, animation, simulation, manufacture and drawing. So in this video we are going to look upon design and your manufacture. So under design we are going to generate a CAD model, and under manufacture we are going to generate the code, that is your G code and M code for that particular CAD model. Before starting with that, here you have one more option of show data panel, wherein you can create your projects. Okay, you can click on new project. I've already created certain projects, so you can click on new project and you can create different projects as per your requirement. There is also an option of file new design. So if you're already into the software, you want to create a new file, then you can click on this file and you can click on new design. Then there is option of save. Then since now we have selected the design, what we can say workspace, here you can see the options of design, that is solid, surface, mesh, sheet metal, plastic, utilities, etc. Now before starting with this, I am going to use the CAD model. I am going to generate it for a CNC lathe job. So as all of us know that with respect to CNC lathe, cylindrical jobs are what you can say a matter of concern. So for cylindrical jobs and with respect to CNC lathe machine, generally the axis that is considered is that along the horizontal axis you have the Z axis, and along the vertical axis either you can use X axis or Y axis. That means along the length of the job your Z axis will be there, and along the diameter of the job your X axis will be there. So if by default the axis which I have over here, the Z axis is vertical, so I don't want this Z axis vertical, I want it to be horizontal. So I need to change this orientation. So I have to change this orientation of my workspace. So from here I will click on my name, I will go to preferences. After going to preferences, a window will pop up, and from there the default modeling orientation. From here what I will do is I will select Y up. Okay, I don't want Z up, so I will select Y up. I will click on OK. Okay, I'll click on apply and I'll click on OK. Okay, now you can see it is not updated over here. So what I need to do is I need to click on here new design. You can see my arrow. I need to click on new design. As soon as I click on new design, here you can see it has been updated, that is Y is up. Okay, so I will what you can say close this previous design. So once you are applied with the orientation, you need to go for new design, and then in that new design that orientation will be what you can say updated. Okay, so I have done that. Now my Z is horizontal, my Y is up. Now in order to what we can say create the 2D sketch, so basically for cylindrical jobs, since they are symmetric along the what we can say horizontal axis, so I'm going to create half sketch and I will be revolving it. Okay, so what I will do is I want the Z horizontal and I want the X or Y vertical. So with respect to job with this cube, what happens is I need to select the right plane. So I'll select right plane from over here. The right plane pop-ups upon your user interface, and then I need to click on create sketch. As soon as I click on create sketch, here the plane has been highlighted. I need to double click on it, and as soon as I double click, what you can say, you can see the coordinate system has been highlighted. Now with respect to CNC lathe machine job, always your program 0 is right end of the job, so your job will be definitely drawn upon the left hand side of the origin. So I'll start drawing my job. So from here the overall length over here is 70. This is as per my drawing. So I'll click OK. Then here the height is 30. I'll click on OK. Then this is my 20. So I just need to move my line option further, and by single click I can enter the value. Then here it's as per my drawing, this value is 10. Single click, the option will be continued. If I do double click, then it will what we can say, clear out. Then this is my 30. Okay, now I'll click on enter. Okay, so as you can see, as soon as I click on enter, my what we can say line option has been cleared out. Okay, now I will draw it from the another. I'll again select line option. I'll click upon this line. This value is my 10. Single click, and then I will join this. Okay, so now my job has been what we can say, my sketch has been completed. Now I need to rotate this, and I will get my 3D model. Before doing that, I have one minor what we can say fillet over here. So I'll go for fillet option and select this first edge, select this second edge, and then it is asking me the value. So the value is 10. So I'll enter the 10 value over here, and I'll click on enter. Okay, so my fillet has been generated over here. Now what I will do is, in order to rotate this, first I need to go out of this sketch option. So here I will click on finish sketch. As soon as I click on finish sketch, I can see the solid options have been highlighted: extrude, revolve, hole. Okay, so now what I will do is I will use the revolve option. Now it is asking me along which axis to revolve. Profile it is already selected, so I need to revolve along this horizontal axis. So I will select this horizontal axis. So as soon as I select the horizontal axis and the angle is 360 degree, my job will be converted into a 3D model. Here I will click on home position. As soon as I click on home position, I can see this. Now I don't want to keep my home position this way, so I want to change this home position. So here is the option of free orbit. So I'll use that free orbit option, and I will rotate this. And what I will do is I will keep this as my home position. This is the home position that I want to keep. So once you have adjusted that, just what you need to do is you need to right click upon this home option and right click. Okay, first I need to come out of this orbit option, so I'll click on escape. Now I need to right click upon this and you select the option set current view as home and fit to view. So as soon as I selected this option, now this is your home view that has been selected. Now if I by chance rotate this anyhow, okay, and I want to bring that back to my home position, so what I need to do, I just need to click on this home, and whatever home position I have saved, it will bring it back to the home position. Simple as it is. Okay, so now I have done with the CAD part, that is my computer aided design. Now I will move to the CAM part, that is computer aided manufacturing, and under this I need to generate the G code and M code for performing this job upon lathe machine. So now let's move under this change workspace. I'll go to manufacture. As soon as I go to manufacture, here you can see the manufacturing options have been highlighted: milling, turning, additive, inspection, fabrication, etc. Now since this is a turning job, here I need to select turning from here. So I click on turning. As soon as I click on turning, you can see the turning options have been highlighted: profile finishing, grooving, facing, okay, profile roughing. So initially what I need to do in your manufacturing setup is, the very first thing is you need to set up the workspace. Okay, what size of workspace you are going to take, what kind of machine you are going to take. So under turning, there is the option of setup. So I'll click on setup. Now here I need to select the machine, so I'll go for select. So there is no machine highlighted over here, so I'll go to Fusion 360 library. There are no machines. I'll click on my machines, local or linked. Okay, so there is no machine available over here, so no issue with that. We will just, since by default if it is not available, no issue. So we will, there is no selected machine over here. Now operation type turning is selected. Okay. Now Z axis is with respect to your face. Now this is very important, because with respect to your CNC lathe machine job, your Z axis is what we can say, sorry, your origin is at the what we can say extreme right end of your job. Okay. And okay, now this is your stock size that you need to select. So stock size Z reference, safe reference Z. So here I will do, okay, this is okay. Offset I will take here as 2 mm. Okay, so when I take this offset as 2 mm, what will happen is I will have an extra stock of 2 mm with respect to your Z axis, that is with respect to with your length. So that I will remove it by using my facing operation. Okay, right here I will select the body. So my body has been selected. No other options I need to select. So here what I have done, see, I have selected the option of what we can say here stock front. I have selected 2 mm offset and I have selected the body. No other options have changed over here. Now in second option I want to select the size of the stock. So here what I will do is I will select a fixed size cylinder, because since this is a solid job, and here the by default maximum diameter is 60, so I will select 20 mm extra stock. So I have selected an 80 mm. The length is 70. I am selecting it 100 mm lengthwise extra. Now the model position. Now this is very important. So what I am going to do is I am going to keep the extra material at the back end of the job. The reason is, as you already know, that with respect to CNC lathe machines, you need to hold the job into the chuck. So definitely you need to have the material extra at the back end of the job. So from here model position, what I will do is I will do offset from front. As soon as I do offset from front, okay, my extra material will be at the back end. Okay, and no other thing I need to change over here. So here what I have done is I have selected the stock diameter, I have selected the length, I have selected fixed size cylinder, and I have selected the model position at offset from front. So as soon as you can see, here is the axis at the front side and your offset it is at the back side. Okay, the last option is your program number. So here you can enter any number of your choice as per your requirement, and under program comment you can give your comment in order to remember. So I am giving it over here CNC Lathe, and I'll click on OK. So now you can see your job setup has been done. Okay, your Z axis you can see it over here, which is along your what you can say length of the job, and your X and Y are along the diameter. Okay, so this is perfectly right with respect to your CNC lathe machine jobs. Now we need to do the operations simulation. So the very first operation that we'll be doing is our facing operation. So under turning you can see the option of turning face. So I'll click on turning face. Now you need to select the job. So here I'll go to select. Under filter I'll be using turning general I'll be selecting under type. Under unit I'll be selecting millimeters. Okay, now we'll go to this another filter. Let's look into turning sample tools. Okay, so under turning sample tool, these are the different tools. The tool that I am going to use is VNMT right. Okay, this tool. The reason I am using this tool is I am assuming that my chuck is rotating clockwise. So if my chuck is rotating clockwise, I need to choose this right R tool. Okay, and VNMT are the most commonly used. So as soon as I just click on select tool, okay, your tool will appear over here. And if you are satisfied with the type that is you have selected, you will click on select. I'll click on select. Here is my tool which is highlighted. Now the next thing is no other changes I'm going to do over here. I'll move on to the second one. So here also I'm not going to do any kind of changes. Then the next is radii, this offset distances. Okay, now here very most important thing that I need to select it. Every one of us know that whenever we are doing the facing operation, we will start from this edge and we'll go towards the center. What happens is that if you go towards the center, there is a small amount of material which remains in a triangular form at the center. So always whenever we do facing, we don't go up to the center point, we go little further from the center point, so that to assure that my facing is happened properly. So under this radii, there is a last option you can see, distance to cut below inner radius. So this is your inner radius, or you can say inner origin. So here I will put a value of 2 mm. So what will happen is my tool will travel further than the center by 2 mm, and that will assure my entire facing has happened. Okay, then the next option over here is my tolerances. So I'm not going to change that. I can use multiple passes over here, so that my what we can say, this happens now. Since I'm using a web axis over here, so that's the reason it has been loaded again. So this is a very what you can say best part of Fusion 360, that even if you don't have your device and you don't need to install your software, you can directly use it on web, like ways right now I'm using. Only thing is, in between, if there is some fluctuation in your network connectivity, it may refresh. Okay, but your work will not go anywhere. So I am selecting multiple passes over here, and no other changes over here. Now I will select on OK. Okay, so once that is done, you can see over here that the stock is there and my tool is there. Now I'll right click upon this. I'll go for simulate. Okay, now under this simulate, you need to select everything. That is, tool should be tick mark, tool path should be tick mark, stock should be tick mark, and under colorization your comparison should be tick mark. Okay, now I will click on play. Okay, so okay, so what happening is over here is already it is showing me a green color, so I need to do a setting over here. I'll just right click over here and click on edit. Okay, I think so there is option of clearance inner, no, tool. Yeah, under this facing model front, we need to select 2 mm. Okay, so that's the reason it was showing me directly green color. That means it was directly showing me that the facing has been done, but I don't want that way. I want an extra material of 2 mm on the front side. So let's do this and check what happens. Now I'll right click and click on simulate. Okay, still it is not happening. Just let me check one more setting. I will edit this. I will keep this back again, model front 0 only. Actually I need to do the changes in the setup, so I'll right click upon this setup. Okay, let me check the right plane. Yeah, I need a 2 mm extra material over here, so I'll right click upon this setup. I'll do edit. Okay, work coordinate system. Okay, my 0 is at over here. Okay, stock front, this is okay. This is also okay. Select Z axis, this is okay. Z axis is okay. X axis from point origin. Okay, let's check this. Yeah, I think so. Here we need to select its offset of 2 mm. Okay, let's check. Right plane. If I do, yeah, right now. Okay, so I've got it where I've been wrong. So that 2 mm extra, that material I need to keep on the front side because I want to do the facing. So that 2 mm extra will come from this option under setup, uh, under your stock, this offset. So your model position is offset from front, and under offset you're selecting 2 mm. So as you can see over here, there is a 2 mm extra material. Now this we will be removing by our facing operation. Click on OK, and now I need to again what we can say regenerate this. So I'll click on edit. Okay, and now I'll click on OK. So now it has been updated. It was red in color, so what I did, I just went upon that face, I went upon edit, and again what I did, I clicked on OK. So it got updated since I have changed the dimensions little bit. I'll click on right click upon this and I'll click on simulate. Okay, now you can see that the entire thing is in blue color, and as soon as I do facing, that particular diameter will turn into green color. That means it will be with respect to my, yeah. So here you can see, okay, and here you can see there is no material remaining, so my facing has happened properly since I have went 2 mm extra forward. Okay, so here I have completed my facing operation. I will click OK over here. I will click escape. Now the second operation is my turning. So I will click on under this turning profile roughing. I will be selecting again the tool. So the same tool that which I use for facing, that same tool will be used for turning. So I'll go on select. The tool is already there since I have selected it earlier. I'll again select the same tool. Okay, no other changes I need to do over here. With respect to geometry also, no need to do any kind of changes. With respect to radii, no need to do any kind of changes. With respect to passes, yeah, now here I am going to use scan cycle. Now why we use scan cycle? So scan cycle is basically used for the operations which are repeated. Now I am going to do the turning. I have a maximum diameter of 60. From 60 I am going to go towards 40, and from 40 I am going to come towards 20. So directly I can't take a cut of 20 mm. So I need to take a small mm cut. So here I am going to repeat the same turning operation for multiple number of times. So that's the reason I am going to use scan cycle. So I will tick upon this scan cycle. As soon as I tick upon this scan cycle, the tolerances, compensation, maximum depth of cut, all these options appear. So I can select it as per my requirement. Here I am keeping it simple. Stock to live. So I don't want to, what we can say, have any stock. So I'll untick this option. Okay, so I've just selected use scan cycle under this passes option, and under linking nothing else need to be done. I'll click on OK. Okay, so here you can see. Now what I will do, I'll right click and I will do simulate. Okay, so let's check how this happens, the turning. So here you can see the turning operation happening. Okay, very interesting. You can see the tool path. Your blue color is your raw material, your green color is your final product. So the turning has been happening properly, as you can see over here. The simulation, in simulation you need to keep everything this on, that is your tool path, okay, your stock, okay, and under stock it should be comparison, then and then only it will show you your raw material and your final product into different colors. Okay, now here you can see certain edges. This is due to the graphics of what kind of graphics you have installed in your what you can say device. Actually it is okay, but due to the graphics you can see those edges over there. Okay, so my turning has happened properly. I'll click on OK. Now the last thing that I need to do is I have done the facing, I have done the turning, but I have taken the length of the job as 100 mm, and actual length was somewhere about 70. So whatever is extra at the back end, that I need to cut. So for that we need to use parting operation. So I'll click on escape, and then under turning I'll go for turning part. Yeah, here it is, turning part. Okay, so what it will do is it will separate the extra material which is at the back end. Now I cannot use the same tool which I use for facing and turning, so I need to select the tool from here. So I'll do is I'll go and select. Now under tool options, what I will do is I'll be selecting turning, and under turning I'm going to select a grooving tool. So basically the tool used for grooving and parting is almost same. So I have selected turning groove. Under unit I have selected mm. I will go for turning sample tools. Let's check whether they are not. Yeah, under turning sample tools. Now since we are going to do external grooving, so we can select an outer groove tool. So from that I'm selecting this type of tool which is pointed. If I select 0 mm, you can see the type of tip it will happen. So depending upon your requirement you can select. So I'm selecting an outer diameter grooving tool. I will click on select. Okay, the tool appears over here. No other settings I will do over here. No other settings need to be done. Okay, I will just click on OK. Okay, and what I will do is I will little bit change the orientation so that you can see whether the grooving is happening properly or not. I will use the free orbit option to check this. Okay, now this is okay. Now I will right click upon this and I will click on simulate. Okay, I will click on play. Okay, little bit slow. Let's play this again. So here you can see, here is your grooving tool. Okay, it is getting inserted and you can see the entire thing is getting, here you can see everything is turned green, so that means the proper grooving has happened and your job has been separated. This is your finished product and this is your extra material. Okay, click on close and click on home position, click on escape. Okay, so that come out of everything. Now the most important thing, that is I need to generate the G code and M code. So once you have completed with all the operations, then you need to go for G code and M code. So from where you will generate the G code and M code? So your G code and M code comes under the option of post processing. So here under actions you have the option of post process. So the under actions will click on post process. Okay, as soon as I click on post process, the post process window opens. Now here the most important thing, you need to select the processor. Okay, so from here I have selected the post processor. From the library I need to select. Okay, then program number you can give your name over here. In comment you can do CNC, what we can say, this is your CNC lathe. Okay, so I'll write CNC lathe. Okay, and then NC extension, create in browser. I'll click on post. No other changes need to be done. Okay, so here the following NC code failed to post. Okay, users. Okay, the post processor has not been found over here, that is missing. So I'll again go to post processor. Okay, here I will go choose from library. Okay, and under choose from library I'll click on link. Okay, so there is no link. I'll click on local, not available. I'll click on the recent. Okay, let's check there if there is a Fanuc controller available, which is generally used. Fanuc. Okay, Fanuc turning. Yeah, so I can select this. I have selected Fanuc turning controller from here. This is a widespread, what you can say, widely used controller. So I have selected a Fanuc turning controller from here. Now I think so it will be not an issue to generate what we can say post processor. So CNC turning. Okay, I'll click on post. Yeah, so now your code has been generated successfully. Here the option pop-ups and here you can click on view NC code. Click on cancel. I don't want to open it into Visual Studio, so it will open it in a browser. So here you can see your code has been generated. Okay, I'll just zoom this so that you can see it. Yeah, okay, so here you can see this is your basic starting operation, starting setup. Then this is your facing code. Then here you can see profile milling code. Okay, then this is your parting code and this is your end of the program. So this is the G code and M code that has been generated with respect to your what we can say CNC lathe job. Okay, now one more thing, important thing with respect. Now also there is one more option of generating the setup sheet. So I'll click on actions. I will click on setup sheet. Okay, I will select my folder. So this PC downloads, select the folder. Okay, and this is my setup sheet that has been generated. So under this setup sheet, what it will show me is, it will show me my entire setup sheet for the program. That is, here you can see, just zoom it out, zoom this. Okay, so here is your job, here is your stock dimensions, here is your part dimensions. So this is your raw material, this is your final product. Then here you have the total number of operation, total number of tools, cutting distance, okay, cycle time. Here you have the description of the tools that you have used. Here you have the description of the operations. So this is also one more wherein you can generate this setup sheet. You can share it with your what you can say manufacturing team in order to get the exact details about the operations. Thank you for watching. If you have any doubts, you can definitely ask into the comment section. Thank you once again.